I've started the recording. This is our design 350. Um, and we're on Google Meet. It's Tuesday. I don't know why that's not highlighting. Try that again. There we go. It's Tuesday the 16th. We're in design 350. We're on Google Meet and we are recording. So let's take a look here. We've got this week we're going to finish up our local infill income generating project. That's our main purpose. Let's look at next week. Next week, we're going to do a new development commercial, and it's going to be a little bit different. We're going to have much the same template, but what we're going to focus mostly on the existing and new development proposal. We're not going to add in as much of the other information because we got a short week here, and then we've got one more week to get it done. And this one, it's going to be a mixed use project, and so it'll be. I think I'd rather have you guys working more on the development of the plan this time through than the documents. And then look at that final portfolio presentation. You'll be putting all of your work together for the semester into one final portfolio presentation. And that actually counts as your final exam. So it won't be due until the end of finals week, which is like there it is, last day to turn in work. That's when it will be due. So we've got one more project after this week. There's 15, week 14 and week 15. And we're going to finish up in our week 13 here, our local infill income generating project. So let's see what we've got here. Pretty much what we've gone over before. We'll be talking about the water supply calculator and the electric load calculator. I think I said them backwards. We're going to do electric load today, maybe. We'll take a look at it. I'm on the VMware and I'm getting some stuff put together. And I think I started out with electrical on the drawing package. So we'll probably do the electrical loads and really talk about those today and look and see what goes on them. Again, we have Wednesday and Thursday and Friday to really delve into these to get them correct and looking good. And then, of course, the submittals are PDFs plus your original files. So let's move over to VMware and see what we can do here. And I think I'm going to need to open up. I wasn't quite as prepared as I thought. Always having to open stuff up in our realm of security and all that kind of stuff. I don't know if you guys had problems, but the push was not working this morning, and I had to do the call me version of it. It looks like they got it back going again. I was freaking out. If that Duo login ever goes down, we're really out of luck. So here we go. I'm gonna get into my Google Drive. Yeah, that would definitely not be good. And we've had that happen before where our server goes down and of course nobody can get to their AutoCAD or their files and things like that. So I mean, if it happens, we'll obviously be well aware of it and be graceful about the requirements that we place on you. You know what? I'm going to not do it that way. I'm going to go through. I'm not going to do it that way either. Here we go. I'll get this right. I want my calendar. There we go. The calendar has everything on it. So here we go. This is what I want. I want our electric load calculator template. That's bizarre. wonder why that template wasn't available. Maybe it's because I made a copy of it. There's the water. There's that one. Okay, good. There we go. And we can go look and see what that electric load calculator looks like. It's really interesting that that's not available. I'm going to go City of Davis electrical service demand calculator. There it is right there. I don't know why that wasn't going right there. But I'll fix it for you guys right now. Not it either. There we go. So that should get us to it. So those are available to you now. Let's make sure that worked. Yes. What do you know? That worked just right. And what we have to put in here. So let's take a look and see where we're at. So I made some new floor plans because I see down here that I need a proposed water plan, power plan, and mechanical plan. And so we're going to focus today on the proposed power plan. So to do that, I need to go all the way up to the top to my plans, and I took my new proposal and I made a duplicate of it and called it new power plan. And I just erased some stuff that I didn't really think I needed, because this is just trying to show where things go and what you're thinking about for this. So I know that there's power available in the street. There's also, I think, power available from those lines that go by. But I'm going to consider that we want one drop to the front corner of the property. And from there, we'll be able to bring what's called a trunk line, a big power cord, and bury it underground all the way over to what would hook up to lot 3. And then we can tap off of that for each lot. And each lot then would have a utility pad. Sometimes that's an actual poured concrete pad with stuff on it. Sometimes it's just a gravel area where the utility people know they can dig and put a box. And sometimes it's just a deep underground dig, like to a water supply or something like that, that's really deep down in there that you're going to connect to. But there's usually an area for a lot. Now, on the lot that my home is on, I've got the water on one corner of the lot and the electrical and gas on the other side of the lot. And so they don't always have to be in one place, but often it can be easier to have all the utilities in one place, particularly if you're going to later on do a dig and want to know where things are. Okay, so I suggested in my concept that I would put one over here and that I would do what's called an easement. So if we zoom in on it, I've got a new power service. And I haven't sized it yet, but we're going to go by Title 24. That's the California Building Code. And so we'll use their calcs. And so you'll notice on the little sheet that comes from the city of Davis, it says California Electric Code. That's one section of Title 24. And so we're going to size it per those. So there's going to be some new power service. And from that new service, I'm going to take a little branch for one lot, a little branch for another lot. And then I decided to bring it all the way around to here. There's probably some existing lines and everything over here, but I've decided that if I'm digging that trench and running that wire, I'm going to put it well out of the way where I think I can then go digging around over here and do whatever I want. I chose, in this case, I've talked about putting it under the roadway, under the common area right of way, but that has its difficulties. So the main one being, as you drive over things, if it's not well compacted, you actually put stress on the items that are down there. So an electric cable doesn't really matter that much. It can bend a little bit, but your water lines and your gas lines and your sanitary drain lines and your internet lines don't like to be underneath roads near the surface. They need to really be down deep, and they need to be compacted properly. And there's usually a zone where, like, the sanitary is the lowest, and it's at -8 feet to 6 feet. And then you've got your cold water from -6 to 4, and then you've got your gas from -4 to -2, and then you've got your power. So there's ways that you run it. But I've chosen to just take what's called an easement in the back. Now, that doesn't mean you can't plant things and have nice things back here. But if anybody ever needs to do work, they get to just come back here in this 10-foot wide strip. And I made it 10-foot wide. It could be 8, it could be 6, it could be 4. But that's just an area that you must give access to any utility worker. And so usually things like fences can be there, but you have to realize that your little piece of fence might be demolished at some point if a utility service has to do work. If you plant trees really close to it, the utility people don't usually like it a lot. But you can put planters back there so long as you know that at some point they might dig up your planter and remove it. You can put bushes and shrubs and pretty much anything that is not really super permanent. And so an easement just means that you have given up the right to utilize that segment of your property for a given use, and that there is free access to the people who are allowed or need that use. So in this case, this is a utility easement. I happen to think there's probably one there anyway because of those wires on those poles that are going past there. So I'm going to guess that there's an easement there already. It doesn't really say in our parcel viewer, but we could probably go look it up if we really needed to. But in any case, so I just drew a line along the property and then offset it, moved it 10 feet, and I call that the utility easement. And inside that, I've got my new power service. I've got a pad, and I decided to make a little 4x4 foot pad. That's pretty big, actually. 4 foot by 4 foot is a really good sized pad. It might actually be like 2 foot or something like that. But I like to, there's plenty of room in this place. And that pad doesn't have to be a concrete pad. It can just be a little graveled in area. And so there's one, and I'm calling it for power, but I will probably utilize that very same one for my water and for my internet and for my drain. Okay, and I did, by the way, I did check to see if in this area who was available. And so I'm not positive that these are all available on that site, but certainly in the 95841 it is. And, you'd have to get with each one of these, and that would be part of the job of the architect to make sure that there was internet available and that you had the concept to get your data hookup also on that big pad up in the front. So that's what we've got there. This is an example of what your new power plan might look like. And then we're going to come over here and I'm going to put it on my sheet list. Proposed power plan. Here it is down here. And I added it. There we go. I've got it on there. And then I want to put a drafting view of my load calcs on there. So I'm going to have to look at those load calcs somehow. Okay, so let me find out where those are. Here they are. And here's where I'm going to want you to use this little template here. Okay, so you can rename it as yours. And you can put your initials on it or something. So now that one's mine, right? That one's mine. And I'm going to create this calculation from this. So you can see I got started. I took all of this information and I kind of looked it over and pasted it into here. So it doesn't work when you just do copy and paste. You actually have to read it, which is kind of a bummer. But we can put them side by side and just go right down there and go, okay, this is my residential calc. Let me do these ones. Nameplate rating. How many of them I've got. What's my multiplication factor and my total? Okay, so for heating and air conditioning, what's my nameplate rating? Maybe, and this would be for, let's call this one lot 1. Now, I don't really care if you have proper and appropriate ones, but pretty much you can go with 1,000 square foot would probably be maybe 4 kilowatts or something like that. So I'm going to put down nameplate rating as maybe 4,000. I'm going to have one of those. And I look over here, my multiplication factor, that's this thing right here, is 1. And so this is going to equal my nameplate rating times my quantity times my multiplication factor. Okay, now on my tiny house, I am going to put 1 on also. And this is maybe a little large. You can always go look it up. You can just go onto Google and find one. 1,000 square feet, 1,500 square feet. How many watts is it going to take? That's a little low. I'll bet you it's more like 5,000. And then I've got a window air conditioner in my tiny house that's 1,000 watts. I can copy that one down. And I've got a space heater in the tiny house that's 400 watts, and I might use 2 of those. Now, the space heater has a multiplication factor of 0.65. So that's what I would put down for my lot 1 for this upper portion. Okay, heating and cooling is for my main residence on lot 1. Window air conditioner is for my cooling on the tiny house, and space heaters are for my heating in the tiny house. So I've got that portion filled out, and that's this top portion up here. Okay, now for my next one, and you can do all your good work of making these things, look good, and that's up to you. You guys all know how to use Excel and Google spreadsheets to make it look good, and this is kilowatt. So you can do all that. Now I have to go down and think about what else is in here. So the first thing I've got is square feet. Okay, so I've got floor space. Okay, and it's 3 watts per square feet times, what's my main residence? 1,500. But I want to add in my tiny house. I'm going to say it equals, and maybe my tiny house is like 200. Whoop. Plus, not times. Let's get that right. Equals 200 plus 1,500. There we go. And there is no multiplication factor on all of these, so we'll just do, and we're not going to go through all of this stuff. I just want you to get an example. But there's a floor space. 3 watts times how many square feet? The next one is for a kitchen. 2 20-amp circuits at 1,500. So this is going to be kitchen, and I'm going to have 2 for the residence. Plus, I think you only need 1 kitchen circuit for a tiny house. So I'm going to say 1. Whoop. Let me do that right. It's 1,500 watts. And I have 2 for the main residence and 1. And that's just, they know that kitchens really take power, and people always plugging big stuff into it. So range, cooktops, and ovens. So range, cooktop, oven. And those are usually between 3,000 and 6,000 watts. And again, you would go look it up. You can look it up, or you can just place something in there. I'm going to put in something like, I'm going to put in a number that's too low. 2,500. No, I'll put in one that's too big. That's a massive one. Okay, you'll want to put in something that's between 3,000 and 6,000. And if you can actually go look up, you know, KitchenAir oven or, whoever makes them, IKEA oven, and just look at the nameplate watts, that's what you put here. And there's going to be one of those. Microwave. Those are usually around 1,000 to 1,500 watts. And there'll probably be one in the main residence and one in the tiny house. Now, if you wanted to, you could do that one of these for the tiny house and an additional one, but I'm using this as everything for lot one. And then you'll just keep going on down the line to get these other things in here. An electric water heater, yep, go look one up. A dishwasher or garbage disposal, yep. A washing machine, I'll put that one in, washer. That's water heater, dishwasher, disposal, and now I got a washer. So you can go look up how much a washer is, but they're telling you what to use. They want one single circuit for it. So it's going to be 1,500 watts, one. Electric dryer. And then you have to look. You can either look at the nameplate rating, and if it's greater than 5,000, use the nameplate rating. That's just what you look up online or on the tag. And you always look to the specifications. Let's just find one. Let's just look up electric dryer. Samsung electric dryer. There's a. Here we go. And you can just go to the specifications. Somewhere along here, you'll see the specifications. It's usually way down, buried at the bottom somewhere. Should be on here. Volts 240. Well, they're not giving you the watts. So I wouldn't buy this one. I didn't see anything on it. That's really interesting. Well, you can't get it from that one, but usually you can get the actual information from it. Okay, so you would have to find one that has that if you were going to put it on there. All right, so you just keep going down the line, and then what does it say to do? It says to subtotal that. Let's go up to here, and I'm going to make a sum of, here's all of my other items right here. I've already done it. Okay, so that's my subtotal equals whatever I get right there. Subtotal. And then what does it say to do? It says take the sum and then subtract 10. kind of weird. And then it says to take that number from above and multiply by 0.4. I'm going to move these down here. So that's going to equal total from above. That's this one times 0.4. Hold on a sec. So right here, transfer the largest value here. Okay, so that's going to be, okay. And so now this is going to be and I'm not doing a great job with my typing here. That's going to equal whatever I had up here. Which was my biggest one? It's going to be that one. Now I have to add 10 more back in. It's like what are they thinking? Now I have to add this and this and this. And I don't know what their thinking is there. That's what it says to do. That's how many kilowatts I'm going to need. Grand total of watts. Really have that many? 8 through 15. Yep. Yeah, those are some big numbers. Okay, and I can redo a little bit of work here. And then my final calculation, grand total watts divided by 240 volts is my service amps. And it says 100.4, but usually we would take, and that's a 100 amp service. Now, it's probably going to be higher than that because I haven't put everything in there. So I'm going to need 100 amps. So I know a few ways to put this into my work. Go back to my Revit. And what will I need up here? I'll need a new detail view, drafting view. This is going to be lot 1, electric load. And then I have to go save this thing and insert it, right? And you'll do this for each one. Lot 1, electric load. And so now I think I can insert that. And I probably want that to be like 6 inches wide, maybe. Maybe even more. Let's just see what happens if I make it 9 inches wide and put it on that sheet. That might be too big by the time I get all three of them on there. Oh, yeah, that's way too big. I need three of those on there. Let me go up and make that much smaller. Let's see what it looks like now. So you can get that one. I don't know why that's there we go. So you'll be able to figure out how you want to place these on here. Right? This can move over a little bit, but I think you can get this down to a size. I might even have to make it just a little bit smaller to get three of them on here, but you would want lot 1, lot 2, and lot 3. Okay, so that would be your proposed power plan. And remember, this one needs to, there is no scale on it, so I'm going to get that display name. So that's gone. There we go. That's the calculation that we want to show on this page, and that way, whoever is doing the utility check can see it all on one page. Okay, got it. That pad, that pad, that pad, and then the total capacity for this line would be the sum of those. So if they were all kind of the same, now you could, if you wanted to, make this for each lot. You could just say, well, I'm going to estimate this for a 2,000 square foot house, even if they only build 1,000 square feet, and a tiny house, and so on and so forth. So if you wanted to, you could make this for each one, or you could do a calculation if you have an idea that lot 1 will have a certain size house, lot 2 a certain size house, and lot 3 a certain size house. You could make them different, or you could make this not just lot 1. You could say each lot. Okay? And that's how they would size this main line coming down here. And if that took 300 amps, they would size and that's at 240 volts, 100 amps at 240 volts. So they would size this wire so that it could carry 100, 200, 300 amps. That's how they would do it. Now, some contractors would go, well, I'm going to size it for 300 to here and then splice in a smaller one here and splice in a smaller one here. They would look at the cost of having a power box and the connectors to change that cable size versus running many hundreds of feet of a larger cable. But that would be up to your actually the final architect or your civil engineer or your contractor, whoever is tasked with making those decisions for the planning purposes, for your preliminary submittal to the planning department. This is fine. It shows that it's done according to the standard. They would all read that and go, oh, yeah, I get it. I know what's going on there. And they would see that that would be, as an example, a calculation for each lot. And we're saying that it's not sized right now. Somebody would have to go do the code count. Okay. Any questions on how to do that power? Did you do power calculations in Design 310?
I can't remember. I know that I know that I've done calculations, load calculations in in a couple of the classes, I think,
Right.
like 1 or 2 of them, but I can't remember.
Okay.
It's been a while.
So this might be a slightly different format than was used, but really is the same information. Okay? And the goal of it is you take your heating and cooling and figure out your biggest load, that's your peak load, your maximum load, and you take a portion of that because rarely is that on at the same time as all of this. And it's just a standard that works very well. They found out when you set it up this way, buildings don't fail and people don't have problems. And they can add stuff on later on. So you do your heating and cooling, figure out the biggest load, and then you figure out all the other little things that all add up. I don't know why they have that subtract 10. And add, it's like it's so meaningless. I don't understand what it's there for, but it's in the code. So we subtracted 10, we added 10, add them together. That gives you watts. And watts are independent of voltage. It's just that's power. How much energy are you using per second, per minute, per hour? How much energy, how fast are you using energy? Okay? And we know that if you know your voltage and you know your watts, you can find your amps. That's just a real common one. Watts divided by voltage is amps. That's just how it's figured out. So that's what we did right here. We did watts divided by voltage, and it's always 240 for a residential. Even though you wire up most of your house for 110, and even though most of your appliances and things actually work on 5-volt DC, those all are transformed down or wired to different legs. What comes into residential houses around here is 240 volts AC. And so we've got our watts divided by 240 equals your service amps. So that's what you want to do for this one. And I think that's what I'm looking for. Now yours can look different. I've seen some really neat looking concepts for how to arrange these lots and do some cool things with them. And so this may not be appropriate for every lot to run it over here. And you can run it underneath the common area roadway. You can. You just have to do a little bit more work on that roadway to make sure that it's well compacted and that everything is at a certain depth so that as you drive over it year after year after year, you don't damage something due to settlement. Okay? All right, so there we go. That's your proposed power plan. On Wednesday, we'll review these calculations and then we'll do the water calculations. That's what we'll do during lab. So that means on Thursday, we'll be able to do the water plan. Everything else, I think, is well set. We're not going to do the mechanical plan right now, but that's where if you needed pumps or sump pumps, or if you had any kind of central um, washing area or anything like that, you would have what's called a mechanical plan to take care of pumping water or ventilation or if you had a central fan or HVAC or anything like that, you would have a mechanical plan. But you're not going to need that for this. We just put it on there so that we had a placeholder for it. Okay, that's what I had to cover. Any questions?
You said that you wanted an electrical load calculation for each lot.
Well, you can either do each lot or you can size it to what you think the largest one would be. Like if you were planning a building pad of 1,200 square feet, 1,500 square feet, 2,000 square feet, right? You could do an electrical demand for each one because they're going to be smaller heating and cooling and so forth. Or you could say, well, I'm going to calculate them all as if they were the 2000. These guys are going to have a little bit bigger service than maybe they need, but they don't have to use all the power, right? And so that's if you want to do just one calculation, base it on your largest lot.
Okay, and then
Just
that would be
put one of
including.
them on there.
Okay, and then would that be including the main residence and the tiny home
Yes.
together?
Yes.
Okay.
That's what I did. If you want to do one for main and one for tiny home, you could. But you know what's really going to happen is they're going to pull off of the box here and run a line over to the tiny home. They're not going to pull a separate line for it. So I think they're all going to come out of one box.
Okay, and then the
Eventually.
box would just be anywhere near the
Yeah, and you
residence.
know what? Electrical is really easy to run. You can run it 2 or 3 feet deep. Any good landscape contractor has a ditch witcher that can cut the thing and drop the electrical line in and run a power in the PVC for, 500 to $1,000 and wire it in. That's the easiest of all the things to do is run the power cord to the tiny house. So that's good. Cool. Anything else?
I had one question as far as the property lines.
Okay.
So when I was doing mine, I went on um, there was the proposed use and then there was the existing. So on the existing, I put the property line, just the main property line
Yep.
around the four corners, and then on my proposed, I separated it up into sections. Well, I noticed that when that was the only, I believe that's the only thing where when I added to it, the property lines also showed up on the existing as well.
They do. You have to hide them.
Okay.
Yep. Yeah. It's a right click hide.
Okay. So I can right click hide it on the existing, but it will still show up on the proposed.
Yes.
Awesome.
So
Okay.
let me go find mine.
Because I saw that on there and I was like, wait a second, like I want them on the proposed, but not the existing.
So here, if you look, see how I've hidden those?
Okay. Okay.
So yeah, you have to hide. And then when I go to my other one, I hide my big one. right? So on the proposal, I hide the main one.
Okay, okay, and you just have the sections.
Uh-huh.
Okay.
And I don't know that you have to, but I thought it looked a little sloppy because they didn't really line up, like the dashes didn't all line up in the right place. So it looked a little sloppy when I had the other one underneath.
Okay.
Cool.
Sounds
Yep.
good. That was the one thing that was, like, bothering me 'cause that it
Yeah.
wasn't.
Yeah. It's like,
Yeah.
oh, what's going on there? That's not right. Okay. Good. All right. Well, that sounds good. I'm going to go ahead and